So class, we will proceed to sight distance. So kanina, pinag-aralan natin is yung sight distance ng mga horizontal curves or what we called horizontal sight distance. Ngayon, pag-aaralan naman natin halos, darating tayo sa point sa discussion natin na pag-aaralan natin yung mga vertical curves naman. Kung paano naman yung minimum sight distance or the safe sight distance sa mga vertical curves natin. So, sight distance is the length of unobstructed view of the driver. Kasi para ma-prevent natin yung mga accidents to occur, we need to consider kung nakikita ba ng driver ng malinaw yung object. So, very crucial to sa pagde-design ng road. Kasi kino-consider natin dito yung visibility ng driver dun sa object. So, kailangan natin i-consider dito yung maraming bagay. First of all, yung driver eye height. Yung height ng object natin, pati yung design speed at saka yung vehicle type niya. So, minsan kasi nagkakaroon tayo ng mga accidents kasi malabo yung mata ng driver natin or sobrang tulin naman ng takbo ng sasakyan. So we need to consider yung worst case scenario sa pagde-design ng mga roads. So we have different types of sight distance. Una dito yung stopping sight distance, also known as absolute minimum. So tinatawag tong absolute minimum. So, ito yung laging makikita mo sa DPWH manual. Kasi, yung mga daan natin is, meron silang stopping sight distance to prevent an accident from a certain object na pwede mong ma-hit habang nagda-drive ka. So, next is yung intermediate sight distance, wherein yung intermediate sight distance, makukuha siya twice mo lang yung stopping sight distance mo. So, yung overtaking sight distance naman, makikita mo to usually sa expressway. Kapag nag-overtake yung isang sasakyan. Next is yung headlight sight distance. Ito naman kapag gabi. Kapag sinabi nating headlight is, let's say meron tayong kotse. So, sabihin natin yan. Yan, kotse. So, kapag gabi, yung mga makikita natin dito is yung mga headlights. Or yung mga rays ng mga sasakyan natin. Or yung mga headlights niya. So, makikita natin. So, nagre-reflect yan sa daan. So, i-consider natin yan mamaya. For now, let's consider first yung stopping sight distance. Stopping sight distance consists of two factors. Yung reaction distance at saka yung braking distance. Kapag sinabi nating reaction distance, it is a distance traveled while the driver perceives a hazard, decides to take action, then acts by starting to apply the brakes to start slowing down. So, let's say, ito yung car mo. So, yan. Tapos, meron kang nakitang obstruction or may nakita kang object na pwede kang magkaroon ng aksidente dyan. Pwede kang mabunggo. Diba? So, kapag nakita mo yung object na yon, hindi naman automatically mapapabrake ka. Meron tayong tinatawag dito na reaction time na kino-consider. Yung reaction time na yun, usually ginagamit natin is 2.5 seconds. And it is applied to the whole range of design speeds. So, gaano ka man katulin, based on studies, yung reaction time daw ng isang tao is usually 2.5 seconds. So, let's say yan na. So, at a certain time, magta-travel ka So, yung tinatawag nating reaction distance. Wherein reaction distance is equals to Vt. So, at a certain time t, hindi mo pa natapakan yung brake ng sasakyan mo kasi minsan masashock ka. Ay meron palang obstruction doon. So, ipaprocess pa lang ng utak mo na kailangan mong mag-brake. So, pati yung kino-consider natin, yung perception reaction time ng tao, which is usually, yung time natin is equal siya sa 2.5 seconds. Next is kapag na-apply na natin yung brake, natapakan na natin yung brake, so yun yung tinatawag nating braking distance. So kapag natapakan natin yung brake, hindi naman automatically magsa-stop yung sasakyan natin. So yung distance na to, yun yung braking distance, V squared over 2G F positive negative G. So, kapag pinag-combine natin yung D1 at saka D2, yun yung tinatawag nating stopping sight distance. So, marami tayong kino-consider talaga when computing for sight distances. Kasi, hinahanap natin yung safest distance. Kino-consider natin yung perception reaction time ng tao and at the same time, yung bilis ng sasakyan. So, in terms of the speed or the velocity, kailangan naka-meter per second dyan. Kung naka-kph yan, gagawin natin is yung velocity natin is di-divide lang natin siya ng 3.6 para maging meter per seconds. So, yung gravitational acceleration natin is usually 9.8 meter per second dyan. Then, meron tayong coefficient of friction. Ito yung friction between the tar at saka yung road mo mismo. So, yung grade of the roadway naman natin, so meron tayong mga daan na pataas or uphill. Meron tayong mga daan na downhill or pababa. So, kapag uphill, automatically positive yan. Kapag downhill or pababa, automatically negative. So, sir, paano naman kung patag yung daan mo? Meron ka bang grade dyan? Since patag yan, yung G natin dito is equals to 0. So, referring to the formula, so, mangyayari niyan is yung G mo dito magiging 0. So, yung braking distance natin for flat roads is equals to V squared all over 2GF. Kasi 0 na yung G natin. So, yun. Yung stopping sight distance natin, it is a combination of reaction distance at saka braking distance. So, let's solve for our sample problem number 1. Find the minimum sight distance. So, kapag sinabi natin minimum sight distance, we are referring to stopping sight distance. To avoid a head-on collision on two cars approaching at 90 kph and 60 kph on an inclined road. So, meron daw tayong car 1 at saka car 2. So, yung bilis ng car 1 natin is 90 kph. Tapos, yung bilis ng car 2 is 60 kph. The first car is moving uphill while the second car is moving downhill. So, uphill yung isa, downhill naman yung isa. So, yung grade natin dito will be positive. Tapos, yung grade naman dun sa car 2 is negative. Kasi pababa. given, so sabi ko nga sa inyo, yung T natin or perception reaction time is usually 2.5 seconds. Yung friction is 0.7, assuming na parehas yung kasasakyan natin. Yung mga friction ng tires nila is parehas na 0.70. Siyempre, parehas silang dumaan sa isang road. So, yung G natin dito is 2%. And a brake efficiency of 50%. So, meron tayong efficiency na 50%. So, hahanapin na natin yung stopping sight distance natin. So, recall lang natin, meron tayong uphill. Tapos, nandito si car 1. Yan. Ito si car 1. Tapos, nandito naman si car 2. Yan, parang spaceship. Pabayaan nyo na. Yan. So, ang tanong is, what is the safe stopping distance na mangyayari? So, kung ano yung mako-cover na distance nito, ito yung stopping sight distance 1. Tapos, ito din. Stopping sight distance 2. So, pag-a-add natin yung dalawang stopping sight distance para makuha natin yung safe sight distance. Plus, so, given the formula na gagamitin natin, SSD is equals to, so, consider muna natin, SSD is equals to V1 times time plus yung V1 squared all over 2F, 2G pala, F plus G, kasi nga pataas, plus V2, V sub 2 times time, plus V sub 2 squared all over 2G, F negative G, kasi nga downhill. So, yung problem natin is, meron siyang brake efficiency. So, yung efficiency na to is 50%. So, yung nangyayari dito is, yung effectivity or efficiency ng brake natin is 50% lang. So, mangyayari, kung na-less yung efficiency ng brake natin, maliless din yung value ng friction natin. So, mangyayari, yung friction natin, magiging 50% na lang. So, kung isa-substitute natin yung mga values, so, kung makikita ninyo, yung mga velocity natin is in terms of kph. So, mangyayari is i-divide natin sila by 3.6 para maging meter per second times 2.5 plus 90 divide natin by 3.6 squared all over 2 times 9.81 0.5 multiplied by F is 0.70 plus yung grade natin na 2% which is 0.02. Plus, yung ano natin, V2 natin is 60 kph, 60 over 3.6 multiplied by the time, 2.5 plus 60 over 3.6 squared all over 2 times 9.81. Tapos yung brake efficiency natin na 0.5 multiplied by the friction plus minus pala kasi downhill siya 0.02. So our safest stopping sight distance is now equal to 233.165 meters. So this will be our answer.